So in the last video we discussed regarding regression testing, right? So regression testing, if you want to recall what exactly the regression testing is nothing but the retest. Okay, a retest in the sense if you made any changes to your code after the acceptance testing, system testing and acceptance testing, if you made any changes to the code, then you have to make sure that the code is actually working fine after the changes. That's why you are doing the regression testing. Okay, so in this video we will just discuss regarding the different levels of testing, and as well as the integration testing, the integration testing in previous uh, you know uh, videos also we have no we have actually discussed regarding the introduction to integration testing and all. So in this chapter also, so of course this module also contains three chapters, right? So it's since it is from a different textbook, so they have taken some concept from textbook 2, and they have taken some concept from textbook 1. Okay, that's why the integration testing they have referred from both textbook 2 as well as textbook 1. Okay, so in the previous videos which I have we have discussed, right, that is actually part of one textbook. In this video also, I mean in this upcoming video, in this video as well as in the upcoming videos also, we're going to discuss regarding this integration testing, right? First let us see what exactly the level of testing is. Okay, so before going to see the level of testing, we should know the traditional view of testing levels, right? Traditional view in the sense we usually from the uh, past few years we usually going to follow some traditional approach like waterfall model, right? For example, here is the waterfall life cycle model. This is also called V model. Okay, so we are going to in the last few from the past few years, the software development process actually involves this model. Okay, people know this called V model. It contains from requirement specification, preliminary and design, detailed design, and then coding. After that coding, we're going to perform the testing like unit testing, integration testing, and system testing. This is also called a V model. So this also, since we act, the software development process involves this model from the last few years. Uh, this is also called as a traditional view. Okay, traditional view of testing levels. Okay, the traditional model for software development is waterfall model, of course, which is done as V, right, in the figure. So in this view, the information produced in one of the development phase constitutes the basis for test case identification at that level, right? This point you need to remember. The information produced in one development phase, for example, the information produced in for example in requirement specification, that actually what constitutes the basis for the test case identification at that level. Okay, so information which is present in this requirement specification, that constitutes some information for testing purpose for that particular level. Okay, if you want to see about the requirement specification test cases, you only need to refer that phase only, no need to refer the other phases. Okay, so we are actually using this model from the last few years. This is some a traditional view of software development process, also called V model, because of its shape, right? Since the early 1980s, the practitioners have devised alternatives in response to shortcoming of the traditional waterfall model of software development. So from the since 1970 1980, up, apart from the traditional waterfall model, so we need some alternative for that one, because they contain some uh, drawbacks and all. To overcome the drawbacks, we have some alternative approach for that waterfall life cycle model. Okay, here in this section, alternative life cycle models, alternative in the sense alternative to the traditional approach, traditional view, alternative to the waterfall life cycle model. Okay, so apart from that waterfall life cycle model, we have some approaches are there. That models we are going to study. Okay. Due to this one, waterfall model of software development shift away from the functional decomposition to an emphasis on composition. Okay, there are two approaches. One is called functional decomposition. Another one is called composition. Functional composition. Decomposition in a sense, we're going to decompose. One unit is there. We're going to decompose that unit into different units. That is called decomposition. Right? What is composition? So we are going to uh, you know club up all the modules into one activity. I mean, if different units are there, we're going to club those units to form one unit. That is called composition. Okay. So the waterfall model which we have discussed now, that is actually a functional decomposition model. Okay. This alternative life cycle model actually follows composition model. Okay. Decomposition is a perfect fit both to the top-down progression of a waterfall model and to the bottom of testing order. One of the major weaknesses of waterfall development is the over reliance on this old paradigm. Okay, either it will follows top-down approach or it will follows but bottom-up approach. So if you have any specification drawback and all, then what will happen? The entire system needs to be changed. That is one of the major drawback of this alternate. The traditional V model or waterfall model. Functional decomposition can only be built in when the system is completely understood. If you know the system well, then only you can decompose that system. If you don't know, if you don't have any idea about that system, you can't do functional decomposition, right? For example, the person who is repairing the TV, assume that a person is there who is actually uh, has a TV repairing shop, right? Because he has the knowledge of the TV, right? TV system, how it's going to work and all. That's why when he is performing his duty of repairing the TV, he is going to decompose different units, right? He will open the TV and he will going to decompose different units and he will going to check each unit. If that person don't have any idea about the TV, is it possible to decompose the TV? No, right? The same way here. If you want to decompose if you want to follow the function decomposition approach, you should have a good knowledge of that particular system. Okay. The result is a very long separation between the requirement specification and the completed system. And during this interval, there is no opportunity for feedback from the customer. So this is the drawback actually. Okay, it's a very long separation process. Okay, due to this one, what is very long separation between requirement specification as well as complete system. From the first stage to last stage is actually very long separation. So in this level, we don't have any time for getting feedback from the customer. That is one of the drawback of this traditional view model. Okay, that's why we're going to why these are all needed. This is for basis for why actually we need a alternative for waterfall model. Okay, that's why it's just an introduction to why actually we need this alternative life cycle models. Okay, due to the drawback of waterfall model, right? So composition, what exactly composition? On the other hand, is closer the way people work. Start with something known and understood, then add it to a gradually and maybe remove undecided portion. That is actually the main idea of this alternative life cycle models. Okay, alternative life cycle model is based on composition, whereas the traditional waterfall model is based on decomposition. Okay, at this point you should remember. What is composition actually? It's something like start with something. If you know something, right? From that point you're going to start. So when you actually writing the answer to your question in examination, you know, actually writing answer to the particular question, if you don't remember actually what actually you remember, from that point only you're going to start, right? When you start to write each point, the point wise, we're going to get some idea about the entire answer, right? This is cut composition. We're going to compose the answer for the particular question. Understood, right? Yeah, that is the main idea here. There are two versions. One is called positive sculpture, another one is called negative sculpture. So this negative in the sense just removing that one, positive in the sense just um, adding that one, something like that. So in negative sculpture, work proceeds by removing unwanted material, completely removing unwanted material. That's all. Positive sculpture is often done with a medium like wax. Assume that a wax is there, so we are going to give some shape to particular wax by adding wax to that one or removing some wax from that point. Okay, something like if you want to uh, make some doll from that wax, what you actually going to do? You will take the wax and you will going to going to give some shape to that particular wax by adding some wax to that one or by removing some wax from that one, right? Uh, so the positive sculpture actually adds the system and are adding as well as remove some unwanted portion also, right? So here the central shape is approximated. Okay, the central shape is approximated, and then so here the central shape is approximated, and then wax is either added or removed until desired shape is attained. Okay, once you get a desired shape, until that if you until you get a desired shape for a particular shape, you're going to add or you're going to remove. Okay, until you get a perfect shape. Okay. With this positive sculpture, the erroneous part is simply removed and replaced, right? The centrality of composition in the alternative model has a major implication for integration testing. So this is the major points. Okay, this is actually based for performing the integration testing, right? Uh, so now we actually start the different version of alternative life cycle model, right? So up to here we discussed why actually we needed the waterfall alternative life cycle model. So here from here onward we're going to discuss what are the different alternative life cycle model. The first one is waterfall spin-off. Okay, this is the first alternative life cycle model. Okay, here actually there are three mainline derivatives are there. Okay, from the waterfall model only. First one is incremental development, another one is evolutionary development, another one is sporadic model. So each of these actually involves series of increments or builds, which actually shown in here. Right? See here. It's actually build sequence, life cycle with a build sequence. Different builds are there, from detailed design, coding, unit testing, integration testing, regression, progression, and all. Right? Here series of builds are there, preliminary design is there, requirement specification is there. So we're going to add builds, or you're going to build each part differently, right? Within a particular build, the normal waterfall phases from detailed design to testing occur with one important difference. Systems testing is split into two steps: regression and progression testing. Here, uh, each build. So, in the earlier version waterfall model, uh, each different activity is considered as a one process, right? I mean, from what each design activity is considered as a different activity, and all the design activity constitute one single process. Here each approach is considered as a build. Okay, different unit of build. In each build we're going to follow the approach. It means this waterfall model approach from detailed design to code, or sorry, from the detailed design to testing. That's what they have mentioned here. Within a build, The normal waterfall phases from detailed design through testing occur with only one important difference is there. That is called the system testing actually are divided into two approaches. One is regression testing, another one is progression testing. Okay, in this waterfall spin-off approach. Okay, uh, and it is important to keep preliminary design as an integral phase. Okay, rather than to try to amortize such high-level design across a series of builds. The preliminary design, you can see here the preliminary design right here in the waterfall V model. A preliminary design is there, right? Not in this model actually. In the waterfall model, we have a preliminary design. The second phase after requirement specification, we have a preliminary design. This preliminary design, right? This preliminary design actually what this preliminary design is considered as an integral part rather than try to amortize such high level design across a series of builds. Okay, is considered as an integral part here since preliminary design remains a separate step. Okay, so it is actually a separate step. We are tempted to conclude that integration testing is unaffected in the spin-off models. Okay, so integration testing actually is not affected by this preliminary design. The main impact of series of builds is that regression testing becomes necessary. Of course, regression, here the main approach is it consisting of different builds. So, I mean builds is nothing but a model, different units. Since units are present in this model, units are present in this approach, you should use this one. What? Which one? Regression testing, right? To make sure that after you apply after you perform the integration testing, you should perform regression testing so that to make sure that it is the system is actually working fine after integration testing. That's why the regression testing is necessary. The goal of regression testing is to assure that things that worked correctly in the previous period, right? We already know this one. Previous period still work with the newly added code, right? Regression testing is that one retest after if or after making any changes to the particular code. You people always remember what is regression testing. Regression testing is nothing but after system testing as well as acceptance testing, you need to make sure that if you made any changes after all the tests, you need to make sure that by executing the revision testing, the model is still working fine after making the changes. So regression, always think that you're going to do regression testing after making changes to the system. Okay. Of course, the regression testing is necessary here. Regression testing is an absolute necessity in the series of builds, right? It's also true here. Build how we the build life cycle with a build sequence is like this one. Okay, just check here, right? uh, First one is in the alternative life cycle model. First one is waterfall spin model. Here it mainly depends on spin, right? Second approach is specification based models. What exactly the specification based model, right? Mm, Recall that functional decomposition is successfully only when the system is completely understood, right? We already discussed this issue, right? So if you want to uh, you know follow the approach of functional decomposition, you should know the system very well, then only you can go for functional decomposition approach. When systems are not fully understood either by the customer or by the developer, functional decomposition is risky process, right? If you don't know the system, don't do this one. If you don't know the different parts of the TV, how actually it's going to work, don't open the TV and don't try to repair your TV parts, right? Same way, if you don't know about the system, if you go with functional decomposition, it is actually a risky process. Under this specification based model, uh, the main model is the rapid prototype lifecycle model. Okay, this rapid prototype lifecycle model actually deals with this by drastically reducing the specification to customer feedback loop to produce very early synthesis. So in this rapid prototype lifecycle model, what exactly the main idea? Main idea is, just observe here. Here we have a life cycle of a rapid prototyping life cycle, right? Here a series of prototypes are there. Yeah? From that series of prototype we come to preliminary design, detailed design, coding, unit testing, integration testing, and system testing, right? And the same way, the series of prototypes, we have another way of traveling, right? In another way of connecting the cycle, connecting the path, right? Customer feedback. So customer feedback, so define prototype objectives, build prototype at the starting level only, before starting the, you know uh, building your software process, software product. You're going to get customer feedback about your system by designing early prototype of your system, right? That is the main approach, or this main idea of rapid prototype life cycle model. That's why here we are going to reduce the specification to customer feedback. From specification we are reduce the specification to customer feedback loop to produce very early synthesis rather than build a final system. So before building a final system, a quick and dirty prototype. Remember, a quick and dirty prototype is built. Okay, quick and dirty prototype is nothing but, for example, you want to build a car. Okay, you want to build a car. So before building the car, before manufacturing the car, we're actually, you know, you actually made a copy version of the car by, uh, something like, in a quick approach, something like, you before building the complete system, before building the complete car, you made a copy of that particular car by using quick and dirty approach. Quick and dirty approach in the sense, you are not actually followed the entire process. You just, based on the specification, you just build a quick model of that particular car, and take the car and go to the customer and ask the customer, and ask if anything change wanted, or if the functionality is working fine, or if you are actually satisfied with this model. Going to ask question regarding that one. That is called getting customer feedback. That's why it is called rapid, quick. Okay, rapid prototyping lifecycle model. Okay, before building the complete system, first we made a copy of that system by using quick approach. Okay, and we're going to take that model to the customer, and we're going to ask whether any changes require or not. That is called rapid rapid prototyping lifecycle. Depending on the feedback, so after getting the feedback, depending on the feedback, more prototype cycles may occur. Okay, if they need any changes, this prototype may occur. Prototype, people know, right? Prototype is, right, is a actually not a complete system, a copy of that system which actually uh, actually possesses the real system. Okay, with a quick building approach. Once the developer and the customer agree that a prototype represents the research system, the developer go ahead and builds the correct specification, right? So after getting the complete feedback from the customer by showing the prototyping versions, after making all the changes, we're going to, start from the specification, and we're going to build a particular system. That is the approach of rapid prototyping lifecycle model, right? This rapid prototyping has interesting implication for system testing actually. what are the important questions we may get from this one? What are the important questions we may get from this model? Where are the requirements? Is the last prototype the specification? So here, since we are actually uh, following the prototype model, rapid prototype model, we may of course have some question like where are the specifications are there? Where are the actual specification to build the copy of the system? Is that last prototype the specification? After that one, right? And that last prototype actually whether it whether it is considered as a specification or not, how our system test cases trace back to the prototype, how to conduct the test cases regarding that one. One good answer to questions such as this is to use the prototyping cycles as information gathering activities. So consider all these activities as a information gathering activity. By in each step of following the prototype, we need to collect information. So this information will be constituted for next further building of process. Okay, and then produce a requirement specification in more traditional manner. Okay, that is regarding the rapid prototyping approach. Another approach is the RISC executable specifications. So actually extension of rapid prototyping concept. Okay, with this approach, the requirements are specified in an executable format, such as final state machine. First one is rapid prototyping model. Second one is executable specification. So the customer then executes the specification to observe the intended system behavior and provides feedback as an same just an extension of rapid prototyping model. Okay, this actually uh, diagram for executable specification, same as the previous one only, right? Executable instead of series of prototype, here we have executable specification, nothing special here. Okay, so here we can here we stop here we can stop now. Okay, in the next video we're going to check, I will going to see uh, the SATM system approach. So in the first model only we actually encounter this issue, I encountered this concept like simple automatic teller machines. We're going to study these simple automatic teller machines in different approaches in the upcoming lectures. Okay, thank you.